day, and I think one more might be joining us. Hopefully they're just running late. So as you guys know, I am Gemma. I'm CEO of the Blockchain Center in Miami, where we focus on mass adoption of blockchain technology. We are also a resource hub for people that need help when it comes to their crypto assets. So definitely follow us at blockchaincenter.com, fill in your email, and you will be able to get updates on our live panels and discussions. We do them all for free, all online, so make sure you follow us just to stay up to date. Now, for my lovely panelists, Thessy, I'm going to let you go first. I don't want you guys to directly say what side you're on. I'm sure people will find out, but just give a little bit of who you are, what's your background.
It's going to be pretty easy to guess. Hi, my name is Thessy Mehrain, and I'm a co-founder of the LeValley project. The LeValley project was incubated in Consensus, which is a blockchain company, and it allows peers to trade crypto with one another across chains, across the Bitcoin and the Ethereum blockchain in an unintermediated way, and without sign up. And it's part of like developing an unintermediated financial infrastructure. And before that, at Consensus, I worked in identity, self-sovereign identity. And I also worked on the first in production provenance tracking tool, also at Consensus. And before that, I was with JP Morgan's corporate and investment bank, and was building trading products, and had also another startup before. That's me.
Very cool. You are a established woman. I'm happy to have you here. And what you're doing with the Ethereum and Bitcoin blockchains with Consensus, I definitely want to ask you a couple more questions about that later on.
Yes.
Dan, go ahead.
Sure. So I manage business development for Symbiont. Previously to Symbiont, I was in quantitative finance. I worked both at Bridgewater and AQR, and before that, banking at HSBC, doing essentially leverage finance for Latin America. And previous to that, I started my career at McKinsey as a consultant within their risk practice. So essentially, I've been mostly within the banking industry. And then what I'm working now at Symbiont is bringing blockchain solutions to the banking world.
Are you a developer, Dan?
I'm not a developer. My master's was in electrical engineering, and I did computer science in undergrad, but so I can defend myself coding, but I would not consider myself a developer, not by far.
Very cool. Yeah, we need a lot of people like that. So for any young people that are watching, even if you don't want to directly code, you should definitely learn at least how to read it. It gives you a leg up absolutely over the competition. So we have two people here who used to be in banking and now are in the crypto space. Kelly, if you want to give an introduction on yourself.
Yes, hi, I'm Kelly LeValley Hunt. I'm an investor in.
Kelly,
you're muted right now.
Muted. Let me unmute her.
I am. Sorry about that. Kelly LeValley Hunt. I'm an investor in the ecosystem in the blockchain space, whether it be infrastructure support or blockchain companies. Prior to that, I took one of the first companies to sell enterprise blockchain solutions to multinational organizations to market. That's Block Apps, the first company to incubate out of Consensus. And prior to Block Apps, I was working in the data center industry for the past 20 years. Multinational organizations were my clients, and began becoming very interested in mining technology and mining solutions for cryptocurrencies while I was working in the data center industry. Thank you for having me.
Yeah, for sure. Thank you, Kelly. That's very cool background that you have. I always am interested when I see people that have been involved in technology for a while, and then because of that, they see the mining, they see all of these different opportunities now in the crypto space, and now they're here. So we have one technology focused person who does banking solutions. Then we have two people who are very involved previously in finance. Now this discussion is permissioned versus permissionless blockchains. To give our audience a preface, Kelly, would you like to explain what you view as the major differences between a permissioned and a permissionless blockchain?
Yes, thank you. A lot of people look at the technology and differentiate between what is black and what is white.
Mm-hmm.
I kind of like to look at it from the perspective of what the use case is, what you need it for,
Mm-hmm.
and what the value of the solution when applied to the challenge, what what you get out of it. So if you're in an environment where you need to share information, but you need to have verification, whether it be a central authority verification or whether you have a verification from an algorithm or a consensus algorithm, it all depends. So if you're in an organization, it's a multinational organization, and you need verification across many different departments, then a consensus algorithm would probably be overdoing it, but perhaps that's what you need. Or you can also say, if you need outside your organization parties to be all in consensus or all in agreement, you might have a consensus algorithm to lay across those decision-making processes. So it really depends on what you need. And a lot of times when in the past where I've gone out to multinational organizations, I've asked them specifically to explain what they actually are trying to do. And then I could say whether or not block apps or going public with an Ethereum solution is the best.
Definitely, that's a good point. Exactly. What is it that the person needs in order for a system to fit them? I do see we have a late comer, Alex. If you want to introduce yourself a little bit, just say who you are, what your background is.
Hey, everybody. So my name's Alex Tsankov. I'm a software developer, and I have been in the blockchain space since I originally started playing with it in 2012 and then started getting really into it with the launch of Ethereum in 2015. Mm-hmm. I've worked professionally in it. I've worked at ItBit, which is one of the biggest Bitcoin USD exchanges out there in New York. I worked at Paxos on some of the private blockchain solutions that they've done. I've done freelancing in the space. I've worked on the largest decentralized application on Ethereum Classic Commonwealth. I've been very interested in the DeFi space for a while. And currently right now I'm working at Bloomberg. So just to kind of preface, everything that I'm saying doesn't represent my employer. It's just me. And I am excited to chat about it because I think that the most interesting thing in this space is the public blockchain. It's these sorts of systems where all of the information is transparent by default, because we have enough systems in the world that are opaque by default. We don't really need to have very many of them. We already have enough systems in the world where you need to ask for permission to be able to participate. So for me, what gets me excited as a technologist about the blockchain is that it is a completely transparent, open system that anybody can join, anybody can observe, and nobody can be censored or kicked off from. And I think that opens up a lot of amazing opportunities, because whenever you give the ability for someone to say this person can join and this person can't join, you've introduced a middleman. And what we know all throughout finance is the more middlemen you have, the more fees that get extracted from the system.
That's
so
right.
Yeah.
Definitely want to hear a little bit more about that, Alex. I think you make a really good point when you say that there are a lot of systems that already exist that are permissioned. So this is an iteration of that. Now, back to what Kelly said in her definition and the difference that she said between permissioned and permissionless. Thessy, do you agree with that definition? Do you have anything you want to add to the definition of a permissioned or permissionless blockchain?
I like the approach coming from the use case, right? So this is the most important thing. What problem are you trying to solve, right? So looking at, are you for or against isn't really the right question. But if you look at why blockchain came about, and I think you're sitting in the Bitcoin Center. So why did it come about? It was literally a transformational innovation. It wasn't to create efficiency. It was really to enable something that otherwise wouldn't be possible, right? So like Alex, that is something that excites me. I'm not saying we shouldn't work on efficiency, and there are tons of use cases for that. And even there, even the banks, for example, collaborating in a consortium has them collaborating. That's already pretty revolutionary. But really coming back to the basics, a public blockchain is permissionless, and is so we also have to probably look at the terms a little bit, because we have a public blockchain, but Ethereum, for example, has also the ability to be privately implemented, right? So you can have the benefits of a private implementation for the beginning because of performance issues or because of particular use cases. We haven't added privacy yet or something, but in the future you can open that up. So if you want to go back to the internet, the early days, I mean, that's an overused example, but I bring it anyways. It's really the difference between the intranet and the internet, right? And so if you look at where AOL is today, I don't know where it is actually, so I can't even find it, but that's literally it, right? So the transformational aspect of Bitcoin blockchain was really that it's censorship resistant, that it's open, that it invites everybody, and then to the open architecture. That means it allows for innovation that doesn't happen in a black box in any kind of permission system, right?
Definitely, adding open source into it really grabs the intelligence of a wide range of people. So Dan, do you have any additional information you would like to add to the definition of permissioned? Well, the original question was, what are the main differences between the two?
Yeah, sure. I mean, at its core, when we're talking about our blockchain, we're essentially talking about a chain, a network of nodes. The permission versus permissionless simply mentions whether or not to run a node you need permission to be part of that club, of that network. That's a very high level definition. There are cases depending on the application where a public blockchain makes sense, and there are other cases where a permission blockchain makes sense. Thessy mentioned the example of a syndicate of banks doing business together. That is a situation in which it makes sense for the banks to be talking to each other within a permission blockchain. You don't want a random guy sitting in Brooklyn with his computer to be part of a network where you are only trading syndicated loans. There's just no need for that, and you're sacrificing speed and privacy and several other issues by doing a permissionless architecture when you don't need those other participants there.
I think that's a good example, and I would totally agree with you that there will be those sorts of consortiums, but I think that all of those are going to settle down into public main blockchains. You're going to have side chains, which are basically like permission side chains, which people can join and have very high performance and could be very fast, but it'll all boil down to a main blockchain at the end of the day, and that will be a public one. And I think it'll be kind of like in the same way that you could have companies that have their own interconnectivity between them, but they all are internet companies at the end. If Google were to set up a high bandwidth pipe with, let's say, another company, they can do their own transfers. But at the end of the day, what Google serves to customers comes over the internet and over the public system. Yeah,
and actually, let me start the controversy here, because there's several points that I disagree with that we have already touched upon. So let me start with one of the example of the intranets versus the internet. I've heard that example many times, but I don't agree that that's a great example of how the blockchains are going to evolve into a future generalized permissionless blockchain, mainly because even right now intranet still exists within organizations, and actually the internet itself is not a decentralized network. You have a lot of servers that all of them are essentially permissioned. You don't have access to go into any random server. Yes, it's a web of connected of connected nodes, but not necessarily means that it's a permissionless. So I don't really see that. I mean, I agree with the example in spirit, but like once you get into some of the details, then it breaks down a bit. Another point.
Can I comment on that,
Alex? Yeah, sure. Go ahead.
You said before that nodes in general are all permission. That is actually not true. I mean, that's the whole idea of blockchain, is that anybody can take part and run their own node. That's one. And then your second argument, that is a convenience, right? I mean, the internet was conceived and initiated as a decentralized technology. It's more convenient to not do it that way because we have all the other services, but you can actually have your own box at home and you can run a lot and do that in a pretty decentralized way.
Oh, completely agree. And actually that is actually the reason why permission chains actually exist. As transaction complexity goes up, people are more willing to delegate the management of certain functions. If you're doing a simple peer-to-peer transaction, just sending cash from party A to party B, public blockchain, perfect use case. If you even want to do something like what LeValley is doing, where you're able to do exchanges, like exchange cryptocurrency across chains, fantastic use case. Simple transaction from point A to point B. Of course, not simple because of the tech details that go into it, but what I mean, in the end, it's a transaction of value from one party to another one. Then if you're considering something like an asset-backed security that, you know, it's backed by some underlying asset, there may be like some payments going on in the background. When the complexity goes up, at that point, it no longer makes sense for people to do that peer-to-peer. Even the example, like, I mean, we've had a lot of pushback and this is changing slowly. Just a second. Even wallet management right now is something that people are very happy to delegate to entities like Coinbase, etc. As the user interfaces get easier, people are more willing to use it. But if there's any complexity, people are more than happy to delegate.
So one of the advantages that I see of the public blockchain that no private blockchain has been able to replicate is that public blockchains have 100% uptime. So the issue with a lot of the private blockchains is because there's fewer entities that are participating. If one of the entities makes a mistake, and I've seen this because I've done private blockchain deployments, someone makes a mistake, they can wipe the database by accident, or they can bring the entire thing down. And that's just a bad design.
Well,
I would say
even
that
an
because
example,
it's centralized, because private blockchains are by nature centralized, it makes it much harder to run them in a resilient way. You look at Bitcoin, or if you look at Bitcoin from a system administrator's perspective, from a technician's perspective, this is a network that has had 100% uptime since 2008 or 2009. Not even AWS, Google Compute, Azure can promise that. None of them can promise that level of reliability. And they say it very clearly in the contracts. They say we can give you, 3 nines, so 99.99% or something like that. But nobody can promise 100%. So that's a key factor, and especially when it comes to financial transactions. The other thing that I would say is from a liability perspective, because the blockchain is sort of self-auditing, it audits itself. If the transaction executes properly, that means that both entities had the parties. It means that all of the participants in the public blockchain no longer need to worry about maintaining very large, in my opinion, like accounting systems, because the system is sort of self-accounting. You can build bots that will go through every transaction that came from a wallet, and you can very easily automate the reconciliation of that. And you no longer have to worry about the compliance burden because you control the server yourself. Oh, what if I rip something out?
Yeah, but I mean, basically, we're right now comparing like apples and oranges. I think, even though we're talking about a technology that might produce at some point a block, right? It's a database technology, distributed ledger technology.
It is database technology. Yeah. Everything is database.
It's all database. So it's glorified database, or it's actually a database technology that's transformational, right? So back to the origin. What is not necessary in a proof of authority environment like a organization that is top down, that's a power structure, right? Top down. One entity in the proof of authority has has the right to make changes, for example, right? So talking about immutability, talking about replacing trust, talking about accessibility. There's an authority that can decide whether or not somebody is worthy or not to take part. It's really a totally different use case. Like Kelly said in the beginning, one is efficiency, and that totally makes sense, right? There are lots of things. And on the way to decentralizing, there are actually a lot of wins as well, right? On a more decentralized structure within an enterprise. But if you talk about, if you want to talk about permission, non-permission, public versus private, so that is not the same actually, right? I want to come back, I said that earlier. Ethereum is a public blockchain. There might be a private implementation, but it is in its core a public blockchain versus other blockchains, not to mention any, that are in its core centralized and will never be open, right?
So I'll give you an interesting example. Oh, sorry.
No, it's okay.
So I'll give you an interesting example, and this happened today, and I think this is a big deal. So USDC, are you guys all familiar with USDC? It's the biggest, one of the biggest stable coins.
Liquidity, yeah, we traded on Liquidity. Mm-hmm.
Beautiful. They today decided it's a smart contract, and they have a function in there that's called blacklist address. And they decided today to blacklist 100,000 USDCs that were attached to an address. So that meant that this smart contract, it's a public smart contract. It lives on the public chain, but because of the way that it's written and because Ethereum is Turing complete, you can run any program you want on it. They can embed permissions into the programs themselves. And that to me is fantastic, because I totally believe if you want to put permissioning, anonymity, ZK snarks, or whatever into your smart contracts, great, go ahead, do it. You have every right to be able to do what you want. But the notion that you need to run your own private servers in AWS that will maintain this blockchain, I don't think that's necessary. So I think all of the permissioning should happen on the smart contract on the application level, and it should be running on top of a completely public blockchain that has no permissioning at all. And you add permissions on top of it as you need for your use case.
So yeah, you guys
I'll give you a very...
Go ahead, Dan. I'm going to let you say your rebuttal, and then I'm going to pop in, but go ahead.
Yeah. No, I was going to say like a very clear example of when running your own server makes more sense than depending on a network. And granted that, yeah, Bitcoin has 99.999% of uptime. I mean, it's never been down or whatever.
That's 100.
Even if you look at centralized databases
and never
or
been
distributed
hacked.
databases, even if you look at centralized database or distributed databases as like, cloud systems, the robustness of those solutions is already like pretty high up there for what banks and other like enterprises need. So I think like going to 100% from 99.99, yes, it's nice, but like you're introducing unknown actors onto the network, and not to mention the fact that unless you introduce sharding and other things that pretty much may be dangerous towards keeping consistency on the network, you're going to end up with a slower network. So there are trade-offs to all of this.
That's okay. I mean, the speed is caught up somewhere else, right? I mean, if you look at banks, the settlement time is like forever. But then if you wait 10 minutes on the Bitcoin blockchain, people think it's long, but no. I mean, everybody seems to be willing to wait days for settlement, So,
Yeah, and so just to do a quick...
If you're dependent on data centers,
Kelly, go ahead.
Sorry, go ahead.
It's okay.
If you're dependent on data centers or any cloud provider, you're not... you're permissioned anyway. Everything is permissioned if you are doing that, unless you're running a node in space, like Space Chain, for example. Even Space Chain, you have to send up your node on a satellite. So we all are dependent on one another, and I've learned that completely in the data center space, which is one of the reasons why I really love the hybrid effect or the hybrid ability to run a blockchain solution and a distributed ledger simultaneously and a database. And I think that the use case actually needs to dictate that. And I know that there's purists out there that believe that you can't be one or the other, but I think with multinational enterprise organizations, I think you're going to have to apply that thought process continually.
One of the main reasons why blockchains have come to fruition, and one of the main reasons why there's hype around it, is because Bitcoin itself, the first blockchain, the reason why all of this exists, has characteristics. Those characteristics being permissionless. I'm sorry. Those characteristics being
that was right.
Very secure, right? And permissionless, yes, very secure, censorship resistant. And now, and having that uptime where banks don't. And even though it is 0.1%, to some people, the ability to not have others that are still unknown. If you're working off of the current system, we still don't know who those people are behind the scenes. But regardless, the security in both situations relies on the integrity of the members, of the integrity of the people that are verifying that these transactions are correct, that the information being put onto this blockchain that's supposed to be immutable is correct. So and I'm going to direct this question towards you, Dan. So let's talk about some of the projects that you currently work on. Now, on public blockchains, we don't know who's running nodes. We don't know who's running miners. It could be some 12-year-old running some mining machines under his bed. It could be us here at the Blockchain Center where we have a node plugged in and we're verifying and routing our own transactions. In projects that you currently work on right now, how many people are these nodes?
Yeah, so just to give a quick background, Symbiont has been working with large financial institutions, and up until recently with our new deal with Grain Chain, we're starting to work with smaller companies outside of the financial area. Mm-hmm. In the cases of, for example, the $1.6 billion ABS issuance that was done along with Vanguard, Citibank, Bank of New York Mellon, and State Street, in that case, it was those 5 parties running nodes.
So 5 parties. Okay. So do you have each company has their own node?
Yeah. In situations like that, you usually have at least each company running its own node. Maybe you have some additional nodes just to to take advantage of the resiliency of a Byzantine fault tolerant consensus algorithm. So if you have either you have 4 nodes or then afterwards, then the better approach is to have 7 and then you go to 10. So you just need to keep on those multiples to ensure you have the most advantage of of potentially a malicious node taking over the network.
Mm-hmm. So Dan, in that case, would you consider that blockchain with 5 people as the ones who are verifying transactions are correct? Would you consider that blockchain immutable?
Well,
yes, absolutely. No, absolutely, because you have even in a scenario, I mean, and of course, eventually you're gonna have more nodes on these networks, but even in a scenario where you have 10 participants, this is an agreement between those 10 participants. You don't need $1 million people to chime in on the FX transaction between some bank in New York and a hedge fund in London. No, you only need the bank, the custodians behind that are going to be moving the collateral, and the fund in London. That's it. I don't know who else you want to be there. And in a permission blockchain, you actually have the advantage of instant finality. You don't have this probabilistic finality that you have to wait for on permissionless blockchains. Granted, there are some permissionless blockchains that have worked around that to provide better finality. But what I'm saying, a permissionless blockchain, once you have something that's committed, it's done. And you have the advantage that if for some reason something was a fat finger or somebody got a hold at gunpoint and something was pushed through a blockchain, you need to reverse it. We're all grown-ups and we're running the network here between us, and then we can just go on and enter a transaction that undoes that other transaction. So in Ethereum, you send the address the wrong address and goodbye.
You can embed in a smart contract exactly what you're talking about, reversibility. There's no reason that if you define your own ERC20 token, you can't have a special function on there that says reverse transaction if it comes from an admin as well.
Yeah, but then now you're introducing the same centralization that you agreed to have in a permission blockchain. So
the difference though is that now
it's just a different implementation of the same issue.
But I'll tell you the difference is that now the record of that reversal is spread out over every computer. You can go look at it on Etherscan. It's exactly transparent what has happened in the past. The concern that I have with a lot of private blockchains is that you'll get basically one entity that's running it and knows exactly how it runs and maintains the block explorer and maintains everything. And
but that works,
if they
works very, very well when you need that, though. If you're one organization and a multinational organization and multi countries and so many different departments having to communicate, you need that consensus algorithm for a one organization. Now, if you're letting in 5 different types of banks or 5 different types of oil and gas organizations that want to build a blockchain solution and everybody has to have consensus, that makes it more complicated and it makes it more difficult. And you're pulling information from a database in which you can change a database. So that's really challenging.
So I think where the problem here is not that we understand that certain organizations, certain industries, they need a level of control. They need a level of customization on what they're using as their store of information. I think the problem that comes up in the industry, though, is that when I ask you, Thessy and Dan, the same question about is it immutable at this point, they both said yes. So I think that if the
is it immutable? Oh, I didn't say.
Sorry. You both said you both Thessy being for.
I was like, yeah, it's not immutable.
Saying that a public blockchain is immutable, yes. Dan also says that a private blockchain is also immutable. You are both saying yes.
Well, I mean, it's just like the logic of it. I mean,
and I understand.
If you just look at like the consensus algorithm, right? I mean, a consensus. I'm very tight on that one, which means like if you look at the Bitcoin blockchain or the Ethereum blockchain in many ways, depends on the implementation. The easiest is the Bitcoin blockchain. You have a network of people who don't even know each other, computers who don't even know each other, verifying a transaction versus, that is the proof of work, right? Versus proof of authority, meaning it's a one voice, whether it's like, across many people, it doesn't really matter. And then the hybrid would be the consortium, where people might or might not trust each other. But I mean, collusion, it's in terms of immutability, that is not the goal of a proof of authority enterprise blockchain. That is not immutability. I mean, that is not needed. I mean, the enterprise is already trusting itself.
Dan and Kelly, is it needed to be immutable?
Yes, it is.
So the question here, and just to finish my idea, was that the problem is that both sides are saying that their chain, their record of information is immutable. And I think that it becomes a little bit confusing to outsiders who are going to come and adopt a private blockchain that is not necessarily immutable. And people like IBM are pushing and saying that this is an immutable ledger when it's not. So the problem is not that it doesn't exist. The problem is that there is messaging that is wrong. So go ahead and say what you're talking about.
I agree. I totally agree. That's why I would, and up to the hype, up to 2017, all of these enterprise solutions were actually called distributed ledger technology. It wasn't called blockchain. I mean, literally, it changed with the hype.
I need to clarify that point because you're referring to something like R3 Corda or Hyperledger Fabric, which are definitely they are definitely distributed ledger technology. They are not a blockchain. Essentially, they are more like a DAG.
But you can ask them.
Graph. But Symbiont, on the other hand, we are actually we stick to a blockchain approach. We are a replicated state machine model. Every single node gets to see all the transactions, but not every single node gets to read all the transactions. So we are actually a true blockchain, unlike Fabric and unlike Corda. So we don't fall.
Okay, then let's get back to what is a true blockchain. If a true blockchain is defined by Bitcoin, then it is replacing trust. Then it is moving agency from the institution to the individual. Then it's a peer-to-peer technology, right? And so enterprise is not a peer-to-peer technology. The structure of an enterprise is like you have decision-making hierarchies, right? Already that in its structure is not represented in the blockchain that you're talking about. That's why I think it's very important to, have the terms clear, because otherwise we're talking about apples and oranges.
Yeah,
so just to be clear,
go ahead and let Kelly
Bitcoin,
go. Okay, go ahead. Go ahead, Dan.
Bitcoin did not define blockchain. Satoshi's paper does not have the word blockchain in it.
Exactly, it's a cash system.
if we wanna define a blockchain, at least my personal definition of it is it follows a replicated state machine model. A state machine is something where, like, for a set of inputs, you always get a defined set of outputs. Replicated because now you have several state machines that when you all agree on the inputs, if you run it all through the same deterministic logic, you arrive at the same output. So essentially, everybody ends up with the same copy without anybody essentially copying from some master computer. For me, that's a blockchain.
So you're solving for truth, for trust. Your definition of blockchain solves for trust.
Well, yeah. Can I just jump in for 1 second, because there's something that's missing right now. Is that blockchain is also about transparency. It means that every entity, every user of the system can verify independently that what they're seeing is true. One of the issues that I have with the private
what is the
blockchain
definition of truth? You can do that with a database as well, and you can take that information as the truth. So we have to get into the definition of what is the truth.
I can say what the truth is. According to Bitcoin, the truth is very simple. The truth is the chain with the most proof of work. That is all that is required. And then the same is true in Ethereum.
Yes, but when you're talking about the difference between enterprise blockchain or a distributed ledger or a database or a blockchain technology, you have to get into the definition of what is truth. And in many enterprise organizations, maybe it's depending on the authority that it comes from. Maybe it's dependent on the consensus algorithm that you implement. Maybe it's dependent on, like Fabric, for example, isn't a blockchain technology. They came out, they said they were a blockchain technology. We understand that there's no consensus algorithm. So what is the truth when it comes to the data? That's really with an enterprise organization.
It's not a blockchain. That the whole idea. And the other solutions are solving a different problem. They're solving efficiency problems. There are tons of great problems to solve, right? I mean, the fact that you can create economies, circular economies, you can create incentives, you can create, it's all very useful. I'm not doubting that, right? So it's not solving for truth. So it's solving for collaboration. It's solving for other issues, right? Yeah. And so that's why it's so important at this point in time, I think, to start defining, when we talk about these things. Blockchain for me means that block, if you say block, then the block has to have some kind of like importance,
and then there's
right?
the hash.
I'm mentioning the block because the block is consequential in my conversation, right? In a enterprise proof of authority situation, the block isn't that important because the block is made up of one verification, right? And that is the verification of the enterprise. So might as well, the block doesn't take a lot of effort to reverse the chain, for example, right? And that's why I don't think that
you can do it instantaneously. You cannot fake the work on Bitcoin. You can with proof of authority.
It's not worth it on Bitcoin, but it is definitely easy on an enterprise proof of authority blockchain.
So just to be clear, at least like when I hear proof of authority is it's just a proof of stake where everybody's vote is worth the same instead of proportional to the stake, where proof of work, proof of stake, and proof of authority are all public consensus algorithms. When you're talking about permission blockchains, what you're talking is leader-follower models, where you're talking about crash fault tolerance or Byzantine fault tolerance. So proof of authority, to be clear, is not for permission blockchains. And also, here's something, I'm going to say something that is very, very unintuitive. Symbiont is more of a blockchain. So Symbiont is closer to an Ethereum than Tezos or EOS because they're delegated proof of stakes. They have specialized nodes.
Putting a high bar up.
in Symbiont, what I'm saying, there's a lot of so-called public blockchains that are taking the route of, for the sake of scalability, they go down the route of specialized nodes. You see that in public blockchains like EOS, Tezos, and a few other ones that went down the delegated proof of stake. And you see that also as well in permission when you look at, for example, the validator nodes in Fabric, the notaries in Corda. Those are specialized nodes. And the moment you have specialized nodes, you start essentially creating subnetworks. And at some point, if you go too far, you end up with a DAG instead of a blockchain.
So let's not talk about
that. I got a question for Dan.
But just to be clear, in the case of Symbiont, we are a true blockchain. So a lot of the points that I think we're talking past each other, mainly because of a misunderstanding of what the true architecture underlying Symbiont is. Because
So I
when
got
you
a
go into the
question.
details, you realize like we are closer to Ethereum than to like a Fabric or Corda.
And why do we need other? Why do we
You
need
have, validating your
Symbiont
nodes.
then? What is Symbiont solving that Ethereum isn't solving, or that Bitcoin blockchain wouldn't be solving?
Well, like a lot. Essentially, like if we look at the way blockchains evolved, you started with Bitcoin, then you needed more scripting on it. I mean, you initially had protocols like Mastercoin and even Counterparty. Actually, CTO and CO were the lead developers at Counterparty. And then some networks evolved into having more privacy. So you have Monero and Zcash, etc. Then other ones went, for the sake of scalability, as I mentioned before, went down the delegated proof of stake to have faster consensus at the paying the price of being slightly more centralized. In other cases, people went like the permission route, where you only have some nodes and combine that with specialized nodes, and you end up with Corda and Fabric. And in the case of Symbiont, we kept to the blockchain where like every node is the same. There are no specialized nodes. We overlaid on top of that. Well, not even overlaid. It's baked into the protocol itself, the privacy of it. And Quorum initially went down that route up until when they implemented privacy, in which at that point they turned more into, they became similar to Fabric or Corda. So we really need to dig deep into the architecture to understand.
So I got a
nuances.
question. I got a question though.
Okay,
So
one more question, Alex, and then
Symbiont,
you guys are going to have to let me run this panel. Okay.
No,
Go ahead, Alex.
This is the thing though, that is, I think that Symbiont, like the way you're describing it, I'm not too familiar, but I think it sounds like great technology. And I think it would be fantastic as a second layer solution on top of Ethereum. Because my question is going to be this: how do members deposit funds or withdraw funds from Symbiont? We're talking about US dollars. How do they get it in and out of your blockchain? Because with Ethereum, it's simple, USDC. I go to Coinbase, I can buy USDC, I can do business with it, and then when I want to get US dollars out, send it back and get my USDC and get dollars out.
Alex, I'll answer that. We don't deal in fiat.
What?
Yeah.
I said I'll answer that. You try not to deal in fiat.
I mean,
no, it's very simple. There's actually
I don't like to speculate.
There's actually a lot of ways.
It goes up or down.
There's a lot of getting value, like for example, assets or fiat into a Symbiont network. One is the way GrainChain is doing it. They actually have payment rails set up with both payment processors and banks. So they actually hold funds in escrow that are then instantiated as tokens onto the network. And by tokens, it may be either a fungible token, as we think of it in public blockchains, or it could also be more like an account-based system where like you simply have a database entry that now says like Alex just received 100 grain pay, for example. We've also been in talks with, for example, aside from payment processors and banks, of course, we've been in talks with several of the very large stablecoin providers, because it'll be very trivial for them to simply run a node on the network, and then just like when they get $1 in and they create that, let's say USD coin or JP Morgan coin on Ethereum, they could do the same on a Symbiont network. It'll be trivial. And actually, like if they actually have a node on Symbiont and a node on Ethereum, you could actually have somebody that happens to have, let's say, Circle coin in one network, easily transfer into a Symbiont network. And also, like if we want to go down the route of what other ways we can get value into the chain, you could have native issuance. If you're talking about CBDCs, for example, which we've actually been approached by several companies to implement, use our technology to implement CBDCs, you have two approaches. One is synthetic, where you simply have a central bank that is holding the accounts with the money that is then instantiated into the network. Or if you have a central bank running a node, that bank can say, I just created money in this network. It's not backed against anything. They're the central bank and they can create money. So essentially they're printed onto the network.
So nothing has changed, right? I mean, we're talking about that's a big, like we're talking about central bank digital currency versus Bitcoin, Ether, other cryptocurrencies. Okay, central bank digital currency has already the word central in it, right? So who is issuing it? I mean, Bitcoin has no issuer; it doesn't belong to anybody. The question is, and again, back to the basics. For me, the social impact and the transformation is really in the fact that, this is changing the game, right? There is no issuer. It's not belonging to any nation state. It's global. Anybody can participate. There are usability issues right now, and we have to solve them, no question. We all agree on that. But it's not trying to put legacy system into into efficiency mode, which that is central bank digital currency. Again, there is a value to that, no doubt, and it will happen. But it's the fiat money, right? It's central bank issued money. There is no difference. It's smarter. You can program it, and that's something you have to watch out for.
Definitely everybody's kind of like talking past each other, because I think that we all do have the same understanding that Bitcoin, public blockchains, these are where the social impacts hit. I don't know if Dan and Kelly are really trying to do the social impact side of things. They're mainly just trying to revolutionize certain industries, make certain industries run more efficiently. But I think where the problem is there needs to be a degree, maybe a different definition and a degree of separation by what we actually consider a blockchain. So and I'm just going to go around the circle and I'm going to ask you guys yes or no. Is decentralization a major benefit of a blockchain? And I'll start with you first, Thessy.
Yes.
Okay, and Kelly, is decentralization a major benefit you can tout when you are trying to upsell blockchain to a company or when you're trying to get somebody to buy into a specific coin?
That's a
absolutely question. I think that's the benefit. It's kind of like, is a mobile phone good for making phone calls? Yes, it can do other things, but that's the whole point of a mobile phone. Going back to blockchain, decentralization, I think, is the main core purpose in implementing a blockchain.
Okay, and Dan, yes or no?
Yep.
So anytime you sell a blockchain to somebody, you're telling them it's decentralized. And Alex, how about you?
I would say that in the core base level infrastructure, yes, absolutely, decentralization is super important. In the applications that run on top of it, the smart contracts, the exchanges, the whatever, it's entirely up to the users. Some users love decentralization and they would only want to use an application that there's no admin keys, there's no ability to take it down, etc. Other users, like, people complain all the time about credit cards. One of the nice things about credit cards is that if I get defrauded, I can call them up and they can reverse the payment. That's a fantastic feature. That requires a certain degree of centralization. So my key is that base layer should be completely maximally decentralized, and any centralization should take place in applications that run on top of it.
Okay, so everybody generally said
you do have to have a baseline of truth.
I'm going to beat all of you guys. Everybody generally said yes, that this is if you're upselling a blockchain to somebody, any blockchain, you would tell your customer, you are doing this and you should upgrade because it is decentralized. Now, I'm going to go around and ask you the same question, but with a number. How many people would you say need to be verifying these nodes? How many computers need to be running the math problem saying this is correct before it becomes decentralized in your vision? Thessy, go ahead and go first.
That's a structural question. That's not like how many.
It is a structural question.
I can say usually it takes 6 verifications, but then the question is in a typical transaction, right? That's a technical question, and it's a structural question. It's by design. Is it 6 people who know each other? No, it's 6 people who don't know each other, right? And so it is a architecture question. Next.
We lost you. We can't hear you.
Eryka, you're muted.
You're still muted.
There we go. Nope. Okay, so for you, something being decentralized means that the nodes have to not know each other and not be conspiring. Yes. So Kelly, and so it could be 3 people as long as they're not conspiring. Yes or no?
Well, that's your sense for security. You can actually, in some transactions, you can actually set how many verifications you need. But usually it's like it goes into the thousands, you know. I mean, it's just like that's the
exactly.
Network.
If it's 6 confirmations is the typical thing to where something is
for
correct.
A settlement of a transaction. Yeah,
exactly. So Kelly, how about you? How many people need to be inputting for you to say that something is decentralized?
As many as possible.
Okay, and Dan?
It depends. If you're talking about a crash fault tolerant algorithm, you would need 3. If you're talking about a Byzantine fault tolerant algorithm, you would need 4. If you're talking about proof of work, I'm not really sure what is the minimum amount of miners you would need to ensure that, you know, the consistency of the network. But it varies on the application and the consensus algorithm you're applying to it. And the application will dictate which consensus algorithm you're using.
Okay. Alex?
I would say that in my ideal, about 10,000 people maintain the state of the network, and that's maintaining the state of what's going on. In terms of actual block producers, new miners, I think that whatever is incentivized by the economics. So in Bitcoin, there's about maybe 10 mining pools that control 90+% of the hashing power. That's sufficiently decentralized in my book. I'm not going to question whether
that sounds like that sounds like a 10-node network, if you ask me.
Thousands.
Sounds like the investment structure.
You simply grab you simply grab a million nodes
coming from the West Coast.
So we answered a different question, right? I mean, one is like maintaining the state of a network versus how many verifications do you need to have to have a settlement. Okay. I'm just
I mean, the question was how many people, because so let's say
to maintain a state, of course, you need more.
Yeah, specifically in the state of Symbiont. Sorry, Dan, how do you say that?
Symbiont. Yeah, you're right.
Yeah, so specifically in the case of Symbiont, how many block producers do you have? Nodes, exactly.
Every single node is a block producer.
Okay, and how many are there?
It depends on the application.
Okay.
I mean, in something where you're tokenizing commodities across a bunch of different grain storage facilities in Mexico, you may have 40. If you have a syndicated loan network with 10 banks, then you may have 10. And then maybe add to that a few custodians. It's like, I mean, in a permission blockchain, you're always going to be talking anywhere from 5 to 50 nodes in general.
Now, to the point of Thessy, she says that these people should not know each other in order for it to be actually decentralized. These people know each other in this case?
Syndicated.
Yes.
No, I'm not sure that's the right characterization of it. Mm-hmm. We could have a 5-node network with the 5 of us, and let's say we know each other and we trust each other. The reason you would choose, for example, a Byzantine fault-tolerant algorithm on top of instead of a crash fault-tolerant algorithm is because regardless that everybody knows each other, we may not trust each other on not getting hacked. I may know Eryka and say like, well, she's at the Bitcoin Center. I know her, I trust her, but I cannot trust that you can secure your node that could eventually be hacked and then act malicious. Mm-hmm. And that would be an argument to do a BFT algorithm instead of a CFT. If we do CFT, we essentially need to trust each other, and to the point that we need to trust each other not even getting hacked. If we want to safeguard against getting hacked, even though you know each other, you need a Byzantine fault-tolerant algorithm.
Okay, now to the point of Alex and to the point of where you're saying 5 to 15, in terms of being decentralized and in terms of getting control of enough people's nodes in order to change what's on the blockchain, would it be much easier to manipulate 5 to 7 people versus thousands of people that you don't know? That makes
it's machines, right? We're talking about computers. We're not talking about people. They're not people saying like, oh yeah, that just happened, and then oh yeah, that happened.
It depends. It depends, right? Because if you're in a permission blockchain, you do have to have some type of oracles coming in and saying this event did or did not happen. Mm-hmm. So it is people.
Yeah. Well, to be clear, I said between 5 and 50.
Nodes can operate without people.
Yes,
and
exactly.
Also you can overtake your vote, and if I'm one person, I have 20,000 nodes, then my node, I'm going to be more powerful than somebody with 5 nodes. So I think there's more clarification and definitions of phrases that we need to be clear on, because I come from a mining background. So I started mining in 2014, and I had 12 ASIC miners when they came out, the first ones to come out on the market, and I was pretty, I thought I was pretty big. I had 12, so now it's nothing. So am I going to continue to mine with 12 ASIC miners? No, because I'm just one person. So we really need to differentiate between how many nodes each person has in the network and how powerful they are, and the consensus algorithm, and how that's steered.
Yeah, definitely.
I would say that I think that the technology
Alex, you want to show your picture?
Oh, sorry. I'm just kind of like, it's not
okay.
working that well. I was just going to say that in terms of Dan's point, I think that Symbiont has a great product. I think it's a fantastic product just based on how you're describing it. I think that what would make it better is if it connected back for final settlement. Instead of using the legacy fiat system, you write a very nice smart contract that has your permissioning for the blockchain, for the private network, and you deploy that as a public smart contract on Ethereum. So that way, anybody who's using this network can determine who has been selected as a member of this consortium, how long have they been a member, getting all of these transparency factors. I think that what Dan is describing is a textbook perfect example of a second layer solution built on top of a public blockchain. But there needs to be the transparency of how someone gets decided, how funds get into the system, how people settle into the system.
The truth layer. That's what, that's why people implement Ethereum, to use it as the trust layer. So there's a lot of protocols out there that claim to be the trust layer. And there's a lot of protocols out there that claim to be the best protocol out there, but it's going back to the use case. Symbiont might be one of the best out there, but it depends on what the enterprise actually wants to have in their environment. Maybe they're an IBM house. Maybe they want to have Hyperledger in there. They want to have Hyperledger Fabric in there. So they have to bring in Sawtooth for a consensus algorithm. So there's a lot of reasons why you have to choose different types of protocols.
Yeah, that's a very good point. And we're going to end on that because we do have another panel that's coming up. What matters is the use case. If something is trying to be sound money, that is permissionless, that is non-censorable, that you can't cut people out of the financial system, it absolutely needs to be something that's a public blockchain that is very transparent. But when you're working within specific industries and you just want to improve the way that people do business on the back end, then you can see yourself use a permission chain. I think the big reason why there's such a debate in the industry about this is just because of the definitions. And we even touched on that in this call, that the base definitions need to be explained a little bit better before people can sell private blockchains to people, saying that they are absolutely immutable, because as you know, nothing is absolutely immutable, especially when you have less nodes verifying the network. Now, guys, thank you so much.
That's not true, but we're out of time.
Yeah.
Just use Ethereum as the truth layer, the base truth layer, and you'll be fine.
So then here's another wrench in the system: isn't Ethereum all run on AWS? Like, aren't all Ethereum's nodes on AWS?
No, that's not true.
If you have 50 banks on a network, they don't care to write their stuff to Ethereum. They just need to know among themselves. And also, there's a concept that on Ethereum, even if you encrypt stuff, there's people storing now and decrypting later. If you go to the quantum computing conferences, there's a concept of Sandal, store now, decrypt later. Banks are not going to be happy about storing encrypted stuff on a public blockchain that somebody may be storing now to decrypt 10 years from now.
That's like 20 years away.
We're more like 5 to 10 years, which is more of a reason to be on a network in which you can control the governance, the encryption, and be able to upgrade it. I mean, there's some public blockchains that can do that already. But I mean,
isn't going to break it.
And back to the basics, Ethereum is a public blockchain and has.
Guys, we're gonna have to continue this conversation another time. It's okay, we will definitely.
It's lovely to speak with all of you. Thank you for having us.
Yes, likewise.
For sure.
Thanks.
We'll definitely continue this conversation. Anna will be in touch with you. Okay. Thank you so much, you guys.
Perfect.
Thank you. Bye bye.
Thanks for hosting.
Bye, guys.
Thank you.
Thank you.
You're welcome.
Okay. Bye bye.